Hello everyone, and welcome to our first session of Office Hours. Today I'm joined here with my colleague Atanas Komarski, and we are going to open up our first session of Office Hours with a really nice talk about why 90 plus page speed score isn't enough. You might ask, what's Office Hours? Office Hours is going to be our monthly live workshop where we're going to talk about everything speed related, from the best tools to use and the most common problems, and also the things that can help you improve the page speed. We're going to cover it all. So while we wait for some more people to join, let me really quickly introduce myself. I'm Elena Kostova from NitroPack, and today I'm going to be the host of the session. Joined with me, I have Atanas Komarski, our technical and performance expert who spends good 8 to 10 hours a day of improving the page speed of our customers and helping them achieve better core web vitals and page speed scores. Nasko, are you excited for today's session?
Yes, Elena, I'm looking forward to the presentation and to the workshop at the end. So there are a few people already watching us live. If you think we can start.
Sounds amazing. So again, welcome everyone. As I already said, today we're going to talk about how you can better understand your performance report, what are the most important metrics that you want to take into account, and how to improve them. The session is going to be in 2 separate parts. First, I would say the most boring one is going to be more technical. We are going to talk about your overall performance report, which metrics that you want to take into account when measuring the success of your site performance. And then Atanas is going to take over with a live demo where he's going to showcase you everything that we're just going to talk about. So let's kick things off. Starting with a really familiar view, I'm sure that almost everyone at some point has screenshotted or sent your performance screen to your friends, your colleagues, maybe you shared it in LinkedIn groups. And up until recently, this was one of the best metrics that you would want to show when you talk about website performance. The reality nowadays is slightly different. What I mean to say is that the speed of your site doesn't necessarily equal your high performance score. And actually what we are seeing in the past months, or even based on our past experience, is that sometimes sites that would load within a second are going to have slightly lower results, performance scores, than sites that load within 5 or 6 seconds. So why is that happening? The reality is that your performance score is based on lab data. Lab data means that your site is tested within a control environment with predefined set of network and device conditions, meaning that everything looks nice on theory, but once you launch your site live, the reality might be slightly different. The benefits of having actually this PSI score and the lab data are really big before launching your site live or when you make changes to your site. So the performance score can be really useful when you're making updates on your homepage or when you're launching new features, when you're debugging problems. Then this metric is going to be very valuable for you to see how most probably your customers are going to perceive your site once it's live. But in reality, the customers don't really care for that score. And let's be honest, no one's going to abandon your cart if your PSI score is 90 or more, or even 50. Like, no one really cares about that. The same applies for your loyal visitors. They don't care about that metric. What they really care is actually their page experience or the experience on your site. And this is why also Google came up with the encompassing metric, the core web vitals. This is where you really see, this is the best reflection of how the user perceives you or the site visitor and how user-friendly your site is. The great thing about the Core Web Vitals is that it measures your site based on the loading speed, on the interactivity, on the visual stability, and most importantly, the data here, it's based on field data or true customer data. It reflects the actual devices, the network conditions, and geolocations of your site visitors. So as such, it really shows how your customers are experiencing your site. The cool thing about the field data here is that it's a cumulative measure, which means that, and it measures within a 28-day period. Why I'm saying actually cumulative, it's because the experience for each of your site visitors might be slightly different. So some users might load the page a bit faster, others may load it a bit slower, and it all depends on different factors like how far the users are physically from your servers or what's their mobile network. So that's why, as I said, it's called cumulative. So it really shows you the truest visitor experience in the most reliable form. Now that we know which is the most important, let's say, area of your performance report, let's dive deeper into how to read it and what are the most important metrics within. So in Core Web Vitals, we have three core metrics. The COS, cumulative layout shift, it shows you if there are any unexpected layout shifts. So for example, if you have table of contents loading slightly later than it's supposed to, some ads popping up or different pop-ups. The other important metrics is first input delay. The first input delay shows you how long it takes for the site to react on the first interaction. Or with other words, it measures how interactive your website is. And the last one is the LCP. The LCP tracks the loading of the largest visible element. Or with other words, it helps you or it shows you how fast your site is going to load in front of your site visitors. So the reality about those three metrics is that most of the times, if you have a stable website that's well built, you're going to pass on the COS and the FID level. What's usually more tricky is the LCP. And at the same time, the LCP is actually the more important metric, if I may call it like this, because ultimately, even if your site is visually stable or interactive, if it loads slow or if it's perceived to load slow, then the whole customer experience is going down. So as such, the most important metric that I would really suggest you to pay attention to and try to always improve first is the LCP. Now, a small side note I would like to make about the LCP, that this metric is not unique for your Core Web Vitals report. Actually, you're going to see it also when you scroll down or in the performance section. Why is that so, and how do those two differ? So the LCP in your Core Web Vitals is based, as we already talked, on field data. So this is the truest value that you're going to get, and it's based on true customer experiences with your site. Whereas the LCP inside your performance core is based on lab data. So a lot of times, if you when you run the report and you're going to see different metrics, don't think it's a bug. It's just different underlying data that creates those values. Okay, so now we already know which is the most important section with the most important metric. Let's see what are the next important steps when running your performance report. First and foremost, what's really important is to, once you run your report, scroll down, go to the recommendation section. And there, I would really suggest to you that instead of applying all the recommendations all at the same time, that you instead run each recommendation one by one, so you can see actually the delta of the improvement. So you can see how each different item actually helped you speed up your site and user experience. Then another small note is, as you all know, the performance reports usually prioritize mobile view. So they show you what your mobile results are. And usually that has a big reason for that. We tend to neglect sometimes the mobile experience, and usually there's the most to be improved. So that's why it's placed first. But don't forget to always check on your desktop improvements and make sure you get that small delta. And finally, the last advice from me is to run tests on key pages. And what I mean by that is think of what's the most important page for your site. For example, if you are a blog publisher, then analyze and run reports on your most visited articles. Or if you're an e-commerce store, then make sure that you run those reports on your product pages. So you get those small improvements that are going to help you get ahead of the competition, and that can help you ultimately increase your conversion rates and bottom line. So with that, we conclude the more technical part, or I would say the boring part, and we're gonna go with the live demo that my colleague Atanas Kamarski has prepared for you. So Nasko, please show us how we can effectively run our reports.
Hello everyone. So my name is Atanas and I'm a tech support expert at NitroPack. I have picked a few websites from the event on Facebook, which you guys have provided. I will go through 3 of them and explain what's happening in the Google PageSpeed Insights window and how to read the data and what actions you can take. If you have any questions, you can leave them in the comments below this video, and I will try to answer them at the end of this session. So let's begin. I'm going to share my screen. For the first website, I have picked the website appseconnect.com, and luckily they have already Core Web Vitals data, which means they get enough visitors to collect this data. And the first thing we are noticing here is that the homepage itself is not passing the Core Web Vitals, as it's mentioned here. But the main reason why the homepage is not passing the Core Web Vitals is the LCP. And judging by the lab test reports LCP of 4.0 seconds, whereas the collected cumulative layout shift across all of the visits from Chrome browser are 3.4 seconds. So, as my colleague Elena mentioned, the two can be different and the lab data is never the real truth. You should always be trusting the LCP in the Core Web Vitals widget. If you don't have the Core Web Vitals widget, you can use the LCP in the lab data as a guidance on what areas to improve. And scrolling down to the opportunities section, we can see that the reduced initial server response time is the thing that's slowing down everything here. And typically, this is the time it takes for the server to send the first bytes of data when the clients request the website. So if the first bytes of data take longer than usual to respond, the first contentful pane is delayed together with them, and the largest contentful pane is also delayed together with them. And you might be wondering then how we can improve the initial server response time. Should we change the hosting provider? Should we get a VPS server or something? Well, technically, the server response time really depends on where the site is hosted and where the actual visitors are coming, if the visitors are physically close to the website, to the server, I'm sorry. Let's say your website is hosted in Europe, but most of your visitors are from the United States. So what happens when visitors from United States visit the website is the data has to physically travel from the United States to Europe and then go back through the same line before the visitors can see the data. This accumulated over many samples will provide worsened statistics because it makes more sense that users are physically closer to the server. So my suggestion is always choose the server location, the location of the server where the website is hosted to be maximum close to the where you expect the visitors to come from. And this is not an isolated case because you might be having visitors from all over the world, for example. You can't place servers everywhere around the world, of course. I'm sorry. To resolve this, you will need a solution like Cloudflare APO, which is a service that runs on their edge network, Cloudflare APO, and it's specifically made for WordPress. What it does, it does cache the HTML on Cloudflare's nodes that are around the world on their CDN. So when visitors request the website, the actual HTML is not delivered through the it's not delivered from the origin server if it's very far. It's delivered from the node that's closest to the visitor. This significantly reduces the time to first byte and improves the LCP part of the metric. The second suggestion is to reduce the unused CSS here. It says that 0.15 seconds are slowed down because of this. So many people use site builders like Elementor, Divi, VS Composer, Beaver Builder, and so. And we don't really have control over how they, what CSS they include and how this CSS is used across the pages. So oftentimes the CSS that is shipped to the browser is not is more than enough for the browser to render the page. In NitroPack, we have a feature where which you can enable, and it allows you to strip the CSS rules that are not used on the current page. This can help with resolving this issue, but also can have some downfalls because it can remove rules that are actually needed for the page to render and can cause visual artifacts. So I suggest if you're using NitroPack and if you are looking to enable this feature, to first make your tests and see if something is not breaking. For this website, the core web vitals we were looking until now was for the home page itself, as it's selected here. But if we go to the origin section, we can see that here the things are a little bit better, but not really. So we have COS introduced, whereas on the home page itself there is no COS. And the LCP globally for the website is lower than the LCP for the home page itself. It was 3.7 on the home page, and here it's 3.1. Luckily, I have access to the Google Search Console of this website. And Google Search Console is very helpful for providing more up-to-date information about how the website is performing and which group of URLs are actually failing the metrics. You can find the Core Web Vitals section on the left side and then navigate to the mobile. Down you will see that the URL, why URLs aren't considered good, and in our case, as we already saw here in the PSI widget, it's the COS issue and the LCP issue, and the number of URLs is identical, which means most likely all of the URLs that fail one fail the other one. So if you manage to fix, I'm sorry, well, we have to go inside actually. I missed this part. Here we can see the URL groups. Recently, Google started grouping the URLs, and it does not report data for one single URL and then collect all of the URLs and make the calculations. Instead, they make group of URLs and they collect little pieces of data for each URL. Then they give the average rating, average score for the group. Here, when we see the COS for this website, all of the URLs here look like blog post pages, which means most of the time they're identical, and we're going to check that in a second. What we can see in this report is that there are actually two examples of URLs that have data, and there are a lot more URLs that don't have enough CLS usage. I have run a test for the first URL already, so you don't have to wait while we are on the meeting. And surprise, there is no COS in the lab test, but the Core Web Vitals widget is telling us that there is 0.18 COS for this URL. So how can we figure out what's wrong when the lab test is not telling us what's wrong? The easiest way is to load the page in mobile version, and in your DevTools in the console, in the network tab, I'm sorry, you should be enabling this feature, disable cache. What this feature does, it disables your browser cache and always requests the most up-to-date resources. They can be cached on the server or they can be cached on a CDN, but they will not be loaded from the browser cache, which is important, because if you have the things in your browser cache, then you're not really testing in real-world conditions, because they're loaded quicker than they would usually do for people who have not visited the website. And I'm going to refresh the page and watch it, just see with my eyes what's moving around to guess what's happening. As you can see, the text here in the upper part, and basically all of the text is shifting. So this gives a hint that Google lab test, the PSI test, may not be catching this movement, but for the visitor, everybody, I believe, can see that the same. The text is the text is first bolder and bigger, and then it becomes smaller. So what we should do about it? If somebody might be thinking it has to do something with the font. Maybe we should change the font, but that's not really the case. For this specific website, and I'm not sure, guys, if you're watching, but you can apply this, and it will help you solve the CLS issue. When we select the text element that's having the CLS, what I'm seeing on the right side is that the element itself is having duplicate font size rules. I'm sorry. There is a media query for the max width of somewhere up to tablet, and there is a media query for the max width also somewhere in the tablet size. But those two, they apply because they're max width. It takes from up to, they translate to up to 1000 pixels. If we disable the one with 25 pixel size for the text, we can see that it becomes larger because the lower one takes precedence. So what we are seeing is like we're making this very quick, and this happens. The same happens in the browser. I'm going to refresh the page a few more times so you can see. So when the browser is loading the CSS and rendering it, it executes the CSS media queries in order of appearance. And because the two overlap with each other, it has to execute one of them and then execute the other one, which is the later. The solution to the COS of this website would be to, let me show you that it's the case for the other text elements as well, because we're not talking here about the header only. This text element, this main area here, is also having the same issue, but it's the other way around. It has three overlapping text rules. So the first one is disabled now. I'm disabling the second one, and the third one is applied. The third one is down here. It's a global text rule, so it looks like you guys have the Elementor configuration for a default text size. So the solution to this would be to make sure that your font sizes are equal on all media queries, or the media queries are not overlapping with each other. What do I mean with not overlapping with each other? When you have this media query, the two say max width. So you first go max width up to 767, and then you go max width to 1024. If there would be different media queries, they would be for ranges that are not overlapping. So here, if we simply change it to min width and continue the media query to set the max width, so it will be in between 1000, or min width can be 767 up to, obviously it's not written like that, I'm just quickly demonstrating how it can be achieved. They're not going to overlap anymore because the actual resolution of the mobile is up to 767, not above that. So that's for the COS. And for this website specifically, all of the pages that have failing the COS are identical and fixing the CLS on one of the pages, because they typically use a template and just reuse the same template. If you fix the template, it's going to also fix the CLS on those pages. The next website I have picked is avukatpetrov.ro, and here we can also see that Core Web Vitals is failed. So we might be thinking, okay, so it's the same thing as before. However, this is for the specific URL we are testing here. That's the home page. That's why my colleague Elena mentioned that you shouldn't be only testing the home page, because it's not really giving the accurate results. When you check the origin data, surprise, we can see that the Core Web Vitals is passed. Scrolling down to the opportunities section, so we are checking the lab data now for the home page itself. If we want to test the other URLs of this website, we have to go to that URL, pick to this page, pick the URL, and run the test through Google PageSpeed Insights. Based on the lab test, this website is having big LCP, which was also reflected in the Core Web Vitals assessment. And also, again, there is a difference. It's the actual recorded LCP is 2.7, but the lab data LCP is 3.1. There are two opportunities similar to the previous website. The first one is to reduce the unused CSS. As I mentioned earlier, we don't really have control over what CSS is the team adding to our pages unless we do it manually. And if you do it manually, try to not have overlapping rules or have a separate CSS file for every page, so you can separate what's loaded in the browser. The next suggestion here, which can help improve the loading time by 0.3 seconds, that's 1/3 of a second, is that the images, well, in that case is one image, is not sized properly. And what means it is not sized properly? When we load the image, we can see that it's a very large one, but it's actually used for the logo in the upper left corner. I have opened my DevTools now, and when you check the image, we can see that the actual size of the image is 1900 x 500 pixels. So this is something big as this, as you can see here on the other side. This big is the logo. But for the browser to render the image here in the upper left corner, it has to resize it, and the actual rendered size is 290 x 76. So it's like 5, 6, 7 times less. So there is no really need to upload such a large image when it's going to be used in a such small area as a logo or something. You can use SVG for the logos because they are very small in size, and SVGs are technically polygons, so the browsers can very quickly render them. And that's for this website, the suggestion. I wanted to show that the homepage can fail the Core Web Vitals. However, the website itself can pass the Core Web Vitals, and the score and the score itself is not really a starting point to predict whether the site will fail. The score of the homepage will not predict whether the site will fail or pass the Core Web Vitals. I was showing websites that were using caching and other mechanics to optimize the website already, but I want to show a website that is not using a caching solution. And the score for this website is like what 30%, 50% of the websites not using a caching solution looks like. I'm sorry. In that case, it's 26 points. So everything is in red. Everything is in red. The LCP is enormous, almost 23 seconds. But from what we can see on the screenshots, the website is not really loading very slow. Actually, if we go to the mobile version of the website, please note that I have disabled cache, so it's going to request it from the server, nothing is cached here. It's average. It's not like the slowest site you have seen. I'm going to refresh one more time. It has a nice animation, things are coming in, so it's pretty useful when you land on the website. But let's see what the opportunities section is telling us and what are the opportunities before a site is using any sort of caching mechanism. For this site specifically, the first one is enable text compression. Text compression is basically a compression either provided by a plugin or on the server itself that compresses the text-based resources, which reduces their size and they're transferred quicker through the network. In this example, just enabling the text compression will help the website owner save 8.5 seconds from the loading time. This is a very big impact, and this can be easily enabled on the server level, either from the site owner or the hosting company can always assist with that. We have the same thing here, reduce unused CSS. For websites that don't use caching solutions, typically what happens is that the website ships all of the CSS together with the page, and this blocks the main thread and it takes a long time to parse. In NitroPack, what we do is we only take the CSS that's the critical CSS that is responsible for the visible part of the page, and we delay the loading of all of these CSS rules that are not really needed for the first visible part. So we can, with NitroPack, you can get rid of this message or at least have the impact of the message lower because there will be only a few kilobytes of CSS that's not used. But in that case, as you can see the numbers here, if you add them up, it's a big number. As a suggestion again, if your team or page builder doesn't allow modifying the CSS or you're not sure how to modify it, you should be using a plugin for caching that generates critical CSS for you and delays the loading of the rest of the styles. In the next example, Google is telling us to eliminate render blocking resources, and this is very similar to the reduce unused CSS part. Technically, it's the same resources. Because they're loaded initially in the browser and they're not delayed, the browser has to parse and render them, and this takes time, so this makes the site slow. The third section is the reduce unused JavaScript section, similar to the CSS. If there are functionalities above the fold that don't require JavaScript, you can use a plugin that delays the execution of JavaScript because the website is going to render fast and it will not be broken because there will be no JavaScript dependent features above the fold. We do this on NitroPack. We have a feature for that. It can be enabled and disabled. This is not something that is tricking anybody. It's just a clever way of loading a web page, and everybody should be benefiting from it. Serving images in next generation formats is self-explanatory. Modern browsers nowadays support WebP and Aviv. Well, not many support Aviv, but WebP, pretty much all of the browsers support them. So if you have the ability to convert the images to WebP, which will compress them better than PNG or JPEG, or if you have a solution that can deliver WebP images to browsers that support it, this will help you get rid of this message. The reduced initial server response time, we already tackled that, and we have talked about it already. Differing off-screen images. This is for the images that are not lazy loaded. So if the images are not lazy loaded, they're sent together with the HTML. Well, the HTML actually tries to load all of the image at once, despite that they are not visible. So you should be using a lazy loading plugin for sure. So you can only load the first 1, 2, 3, 5 images, as many as are visible initially, and the rest of the images will be loaded as you scroll down. I think that's the whole rundown for now. Elena?
So yes, thank you, Atanas. It was very educational. I myself learned great new things. I'm seeing that we have one question in the comment section. Let me know if you want to take this one, but let me also read it out loud. How can we reduce the impact of third-party scripts? What do you think about that?
So third-party scripts are typically chat bubbles, external services that you can use for tracking services like Hotjar, Google Analytics, Facebook Pixels, chat widgets. I already mentioned them. Reducing the impact of them is there is a very simple solution to this. It really depends on the use case, but delaying the loading time of those resources will be impactful to the initial loading time. Because if you don't delay let's say you have a chat widget on the lower right corner of the page, and the code for this widget is loaded along with all of the other JavaScript on the page. So it will try to render the widget and show the widget early. But this widget doesn't really provide any value to the user before the user can actually see what's on the page. So it's not worth sharing the loading time with the widget. You can delay the loading of the widget, and this can be achieved by manually modifying the code with simple JavaScript, like set timeout. There's a function in JavaScript that you can use. Or you can use a caching plugin. Almost all the caching plugins, they have a feature to delay the loading of specific JavaScript snippets. As I mentioned, third-party scripts are also Google Analytics scripts, Facebook tracking pixels, TikTok pixels, Hotjar, etc. So it really depends on what are the goals and how the users behave on the website. For some websites, it's suggested to remove those scripts from the initial render and load them in let's say 5 seconds. But for some use cases, it's not really recommended. So if you have a thank you page, for example, if you're an online store and you track conversions on the thank you page, you cannot afford to delay the script because it has to load as soon as the visitor hits the page, so you can track the conversion. Else you will be missing important marketing data. But let's say you have a catalog page and single product pages. It's safe to say that you can delay the execution of JavaScript-based tracking pixels on those pages with 3-5 seconds, for example, because the users are going to engage with the page anyway, and 5 seconds are not very long time. So the scripts will eventually load, kick in, and track whatever the users are doing. But this is very specific, and you have to be very careful about it.
Yeah, sounds like something that's not that straightforward, as you just said. We just came in with a different question from one of our users. Is after turning the reduce and used CSS option, the website became broken. How can we solve that? Have you encountered such issues, and how do you usually come around that?
It sounds like you have enabled the reduced and used CSS in NitroPack, if I'm understanding correctly. Thank you for the question. The website, when you use reduce and use CSS, the feature, the website can break because of many reasons. And I cannot give an answer straight away, but we have methods of identifying which CSS file is breaking or what exactly is breaking. Because what reduced and used CSS does is it simply checks what's on the page and compares the CSS that it has, and it only creates a new CSS file that has rules for the elements that are in the HTML. But if there are items that are loaded with JavaScript that initially don't exist on the page, the CSS will not be included because the system that removes the CSS didn't see them. It didn't know that it will need a CSS for them. In that case, I believe we can check that for you and follow up later for your specific use case. And I believe we can find the root cause and resolve the issue.
Sounds amazing. Thank you, Tanas. And I think because we're approaching 45 minutes already, I suggest that we take one last question. And it's actually a question that came in our community group from Adam Bartlett. So she said, "Hi. So I help manage a WordPress site, and a WordPress developer consultant suggested that we use NitroPack. I'm loving it so far, and it really boosted our site's performance. But WordPress keeps recommending a persistent object cache. Will this run into compatibility issues with NitroPack?"
So object caching, in simple words, is caching the queries to the database that the website makes. So it doesn't have to make queries to the database every time. Let's say when I visit a page and it has to show me you have 10 recent blog posts. If you don't have object caching, what happens is I request the page and WordPress itself has to fetch the information, the titles, the images, the content itself from the database, and then render the page and show the page. When you have object caching, it's going to cache this content in the middle between WordPress and the database, and it's going to reduce the load on the database. This is helpful if you have many visitors and you don't want to overload the server. It doesn't conflict with NitroPack because what we do, we optimize the front end, we optimize the HTML, CSS, images, JavaScript, etc. And we don't really touch the backend. We don't play around with the database. So you can use the two simultaneously, and there will be no impact on the website. Actually, it's going to be quicker.
Sounds amazing. So I think with that, we can close the session. Let us know if in case you have more questions in the comment section. We are going to make sure to answer them afterwards. But for now, we conclude our first session. As we said, this is going to be the first session of many. So let us know in case you want to hear other topics and what's really interesting for you, so we can cover it next. And I really thank Atanas for walking us through the performance reports and the most common errors and how to actually we can fix it. So thank you, Atanas, and thank you everyone for tuning in today.
Thank you for hosting it, Elena. I'm looking forward for the next sessions. And if you guys have any questions, please ask them. We'll be happy to help.
Thank you. Bye.
Bye.